Welcome, listeners, to another My Mind MashUps deep dive, where we unravel mysteries, spark curiosity, and make sense of complex ideas together.
And today, we are tackling something that I think hits a real nerve.
It's this invisible price tag that feels like it's attached to every single question you type into a chatbot.
Exactly.
And I really want to start by just, setting the scene, because I think we've all been there. It's late. You're maybe putting off some real work, and you ask an AI to write a haiku about a hamster wearing a tuxedo.
It's fun. It feels instant. It feels like magic.
It feels weightless. It's just words on a screen. But then, you're scrolling your feed later, and a headline pops up that says, AI is drinking up our rivers.
Or chatbots use as much energy as a small country.
Right. And suddenly that little hamster haiku feels heavy. You get that pit in your stomach, that feeling of, oh no, did I just melt a glacier because I was too lazy to write my own email?
That's the AI guilt. It's a very real kind of shame narrative that's been building up.
So our mission today is to cut through that emotional noise. We aren't here to defend AI, and we're definitely not here to be doomers. We want to find the actual receipts.
Is the cost really car trip sized, or is it closer to, say, charging your smartphone?
And the answer is really fascinating, because it's not just one number. It totally depends on what you're asking.
And how you ask it.
Before we get into the nitty-gritty, and we have some really surprising numbers coming up, don't forget to like, share, and subscribe if you enjoy content that makes you think.
It really does help us keep these deep dives going.
Okay, so let's start at the beginning. I type, give me a recipe for pancakes into a text bot.
Yeah.
What did I just cost the planet?
This is, I think, where we need the biggest reality check right out of the gate.
Okay.
Looking at the consolidated research, the impact of a standard text query is measured in grams of CO2, not kilograms.
Grams. Okay, that sounds incredibly small.
It is small. Specifically, a typical interaction uses something like 0.001 to 0.01 kilowatt hours of energy. In carbon terms, that's maybe 2 to 5 grams of CO2 equivalent.
Okay, 0.01 kilowatt hours. That's one of those numbers that just slides right off my brain. Can you give me a real-world anchor for that?
Yeah, for sure. Think about charging your phone. If you were to send about 100 text queries to an AI, which is a lot of chatting.
That's a huge conversation.
It is. And that energy use is roughly equivalent to charging your phone to 100% twice.
Wait, so one single question is, what? A tiny fraction of my battery icon.
Exactly. It's a spoonful, not a bucket. For text, the whole narrative that you're personally boiling the oceans with one prompt just doesn't really hold up.
That's surprising, because I always hear about these massive energy numbers, gigawatts, terawatts. If my prompt is so cheap, where are those numbers coming from?
That comes from confusing training with inference, and this is a really crucial distinction.
Okay, break that down for us.
So training is the big bang. It's the creation of the model. It takes massive server farms running full out for months, just crunching the internet to learn patterns. Like, training GPT-3 took about 12,287 megawatt hours. That's a huge one-time energy burst.
That's the big, scary headline number.
That's the one. But inference is what we do. It's the day-to-day use. You asking for a recipe, me asking for a summary. And once a model gets popular, inference actually makes up 60 to 90% of its total lifecycle energy.
So the giant training costs get spread out over millions of users asking billions of tiny questions.
Precisely. The marginal impact of your single text question is tiny.
Okay, so I shouldn't lose sleep over the hamster haiku, but that's just text. We aren't just typing anymore.
No, we're generating images, video, code.
I mean, this is where the math changes, right?
Completely. The modality, what kind of media you're making, it matters immensely.
How big of a jump are we talking?
It's an order of magnitude jump. The data suggests that generating a single image, just one picture of that hamster, takes about as much energy as fully charging your smartphone.
Whoa. So one picture is the same as 100 text prompts?
Roughly, yes. Depending on the model, it's about 60 to 100 times more energy intensive.
Why, though? Why is it so much heavier?
Well, think about what it's doing. With text, it's just predicting the next word. It's a probability game. But with an image, it usually starts with just random static.
The old TV screen.
Exactly. And it has to refine that pixel by pixel, doing millions of calculations to denoise it into a picture that makes sense.
So text is a light jog, and making an image is like a deadlift.
That's a great way to put it. To give you another context, one AI image is about the same as leaving a standard LED light bulb on for 10 hours.
That feels more substantial. If I'm just playing around generating 50 versions of a logo,
yeah,
that's going to add up fast.
It does. And if you move to video, the cost just jumps again. Generating just 5 seconds of AI video can use between 0.5 and 0.8 kilowatt hours.
Okay, let's ground that one for me. What's that in, like, my daily life?
Let's use the driving metric. One AI image is roughly equivalent to driving a Tesla Model 3 for about half a mile.
And what about a gas car?
In a gas car, maybe 20 feet.
20 feet. Okay, so it's not a road trip.
No, it's not a road trip. But the danger is in the scale. You generate thousands of images, you've basically driven across town.
So text is cheap, images are pricey.
Yeah.
But there's another thing that scares people even more than electricity. Water.
Ah, the AI drinks rivers narrative.
Yes. I've seen the headlines. Is it true that every chat I have is pouring a bottle of water out?
This is one of the most misunderstood parts. We have to separate withdrawal from consumption.
Okay, what's the difference? To me, if you take the water, you took the water.
Not quite. Withdrawal is taking water, say, from a river, running it through the cooling system, and then often putting it right back.
So it's not gone forever.
Right. Consumption is the water that's actually lost, mostly to evaporation. When data centers use those big cooling towers, water turns to steam and just floats away. It's gone from the local watershed.
So when headlines talk about withdrawal, they might be counting water that just gets returned.
Exactly. But if we look just at consumption, the water that's actually lost, a medium text conversation, say 20 to 50 queries, consumes about one 500 milliliter water bottle.
That's for the whole conversation, not per query.
Right. Per single query, it's just spoonfuls. Maybe 10 to 50 milliliters.
That seems manageable.
It is, if the data center is in the right place. And this is crucial. Location matters a lot.
How so?
If your data center is in, say, a Nordic country where it's cold, they can just use the outside air to cool things. Water consumption is almost zero.
But if it's somewhere hot?
If you're using evaporative cooling in a hot, water-stressed place like Arizona, you're consuming way, way more water.
So it's not just what I ask, it's where the computer answering me lives.
Ah.
And as a user, I have no idea where that is.
Exactly. It's a huge variable.
Wow. If this is resonating with you, definitely hit that subscribe button so you don't miss the next deep dive. We try to bring this kind of nuance to every topic we cover.
And the nuance is key here, because without it, we just end up in that shame spiral.
So should we feel guilty? Or
Yeah.
just not worry about it?
I think we need to put it in context. Let's play the comparison game. You watch Netflix, right?
Probably way too much.
Yeah. Okay, well, 1 hour of HD streaming creates a carbon footprint that's equivalent to dozens, maybe even hundreds of AI text queries.
That's a good point. I don't sit there watching a movie thinking, oh no, the polar bears.
And let's go back to driving. Driving just 1 mile creates about 400 grams of CO2.
Okay, so do the math for me. 1 mile in my car equals how many text prompts?
It's somewhere between 80 to 200 text queries.
Wow. So if I drive to the grocery store, that's thousands of AI prompts worth of carbon.
Precisely. And that leads to the commute argument. If you use AI to work from home,
Right, maybe it summarizes a meeting so I don't have to drive to the office.
you've avoided a 5-mile commute. You've theoretically saved a massive amount of carbon, even if you send 500 prompts that day.
So in that case, the AI is a carbon saver, not a cost.
It's all about displacement. If AI replaces a carbon-heavy activity, it can be a huge net positive.
So the verdict is, treat it like any other digital thing, like email or streaming. It's not some unique moral failing.
Correct. But
Oh, there's always a but. I knew it wasn't that simple.
there is. Because while your individual click is small, the systemic costs are where the real problems are hiding.
Okay, what are the hidden costs?
First is the always-on problem. There was a study on a model called Bloom, and they found a huge chunk of energy wasn't from answering questions, it was just keeping the model hot.
Hot, you mean like idling?
Exactly. These massive GPUs are just drawing power 24/7, so they're ready to answer instantly. It's like leaving your car running in the driveway all day, just in case.
That sounds incredibly inefficient.
It is. And then there's embodied carbon. We obsess over the electricity to run the AI, but we forget the cost to build the hardware.
You mean the actual chips, the H100s we hear?
Yes, mining the materials, manufacturing the silicon, shipping them around the world. That can be 30 to 40% of the total environmental impact over that server's life.
So even with green electricity, the chip itself has this heavy carbon backpack.
And finally, there's the Jevons paradox.
Ooh, I love a good paradox. What's that?
It's an old economic theory that says as technology gets more efficient and cheaper, we don't use less of it. We just find more ways to use it, so the total consumption goes up.
Oh, I get it. Like with LED lights. They use almost no power, So instead of just saving money, we started lighting up entire buildings for decoration.
Exactly. As AI gets cheaper, we'll put it in everything. Our toasters, our toothbrushes.
And the sheer volume could overwhelm the efficiency gains.
That is the real systemic danger.
So what does this all mean for us? I mean, like, comment, and subscribe to hear more of my Mind Mashups deep dives. But seriously, how do we use this stuff responsibly?
I think it shifts from a feeling of guilt to a need for strategy. Don't stop using AI. Just stop using it inefficiently.
Okay, give us some actionable tips.
First, right sizing. You do not need a massive frontier model, like a GPT-4, to just sort a list of names.
Right, that's like using a flamethrower to light a candle.
Exactly. Use small language models, SLMs. They're tiny, efficient, and perfect for simple tasks.
Okay, tip number 2.
Modality discipline, we touched on this. Don't generate a video if a block of text will do the job.
Don't make a 4K image for a throwaway joke. Got it.
And number 3 is token discipline. Keep your prompts concise. The energy scales with the length of the input and the output. Don't ask for a 2,000-word essay if you just need 3 bullet points.
It really just comes down to being a mindful, smart consumer.
And remembering that net positive potential. If AI optimizes a shipping route by just 1%, the carbon savings can outweigh the compute cost 1,000 times over.
So it's a tool. It can burn energy or it can save energy. It all depends on how we decide to wield it.
That's the core takeaway, really.
Okay, let's wrap this up. AI has a footprint. We can't deny that, especially with water in certain locations and the hardware itself.
But the personal shame that a lot of us feel is often misplaced. It's not about being abstinent. It's about not being wasteful.
Before we sign off, I want to leave you with one final thought. We worry so much about the prompt we just sent, but what about the invisible infrastructure that's being built right now?
That's the big one. We are building these massive data centers, straining grids, all to anticipate a demand that hasn't even fully arrived yet.
Are we building the grid for a future we actually need? Or are we building it just because we can?
Something to think about.
Drop your thoughts in the comments. Your perspective could shape our next deep dive.
We really do want to hear if this changed how you think about your daily AI use.
Find my Mind Mashups everywhere you listen. Amazon Music, Audible, Facebook, Pocket Casts, Spotify, TikTok, and YouTube. Thanks for diving deep with us today.
See you next time.